Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at some functions related to our numerical demo and our numerical driver. Particularly, we're going to take a look at some numerical integration functions. Now, the first thing that you want to do if you're just starting off with this series is you want to go ahead and create a new project called numerical_demo. And you also want to create a main that we're going to call numerical_driver.c. Once again, this is going to be part of a larger series. So if you're just starting off with us now, then what you want to do is make sure to obtain a copy of your numerical_integration.c, which is effectively just a large comments file. And particularly what we want to do this time is we want to focus on the functions associated with numerical integration. So I'm going to walk you through the steps of setting up our file. And then as we add features later on, we will also update our main. So to begin with, we want to go ahead and copy the function signatures found under the functions section of the instructions. And we simply want to paste them over into our source file, and we want to convert these then over to function prototypes. Now, you can do this manually one at a time, or you can leverage the Control-H or find and replace to simply replace all of the leading comment characters with essentially an empty string. So if I go ahead and hit replace here, then you'll see that we've quickly cleaned up multiple lines. At the end of each one of these lines, we want to provide a semicolon. And so we're going to go ahead and go through. And then for the lines that are not directly associated with a function prototype, we would like to turn these back into comments using inline comments. And we can then align them with the end of the appropriate function. So in this case, you'll notice that the first function 01 is then defined as y equals to -x² minus 2x plus 1, and so on. We can continue on with the rest of our functions just by providing semicolons then at the end of the function name to turn them into a function prototype. Now, the last part that we want to do is we also want to include a help. And specifically what we want to do is we want to have a void return value for help, as well as accepting a void input argument. And from here, we're then ready to turn these function prototypes now into the functions that we are going to work through one by one in separate videos to then finish out this particular series, or at least to start on this series rather. Also note that we're in this video going to focus on the main and the switches associated with calling these functions. So to begin with, we want to simply copy our function prototypes down below our main and start converting them then into the implementations. And so we're just simply going to remove the semicolon and essentially just replace them with open and close curly braces. You can go ahead and provide yourself with a little bit of extra space between your functions, basically to improve the readability. Now, when you get to these functions that also have comments in them, you can decide where you want to put the comments. I'm actually going to move them up to the description field when we start documenting these functions. But for right now, you can simply push the comment to the end of the function implementation. Continuing on, you just simply do the same with the rest of your function prototypes. And as you see, I'm simply adding an extra line in between them for readability. And lastly, then we have our help function, which we can go ahead and take a second to go ahead and start by introducing the printf that will define then the usage line or the instructions, the introduction to the instructions for the help. Now, let's focus on getting some of these functions set up. And if you'll notice that most of these functions, with the exception of our help, have a, lost my F there, printf, have a double return type. So the first thing that we want to do is we want to go ahead and create a temporary variable called results. And we want to initialize then results equal to 0.0. And then we want to return our results. And so all this does is this guarantees then that we have functioning code. The last thing that we want to do then with our first function, before we really get started with any of our functions, is simply to set up somewhat of a template that will help us get started on identifying which functions are being called when we are setting up our main. And so what I encourage you to do is simply add a printf inside of our function here. And we're going to leave this alone for right now. We're not going to put anything in there. We're just going to simply have a printf. And what we're going to do now is we're going to copy these 5 lines to each one of our functions. So basically just copy and paste and repeat until you are done with all of your functions. Now, what you want to do is you want to go back up to your first function, and in the printf, you simply want to either type or copy and paste the function name inside of the printf, and you can also add a friendly message if you would like, something like calling and then the function name. I'll leave that part up to you. But essentially what you want to do is you want to identify that this function is being called even before we write any code to do anything substantial in any of our functions. Later on, we can comment this out. And once again, you can leave calling in there. At the very least, just simply put that you are, you put the function name inside of the printf. Now, I'm going to continue this once again for each one of our functions. And notice that I'm adding a new line at the end of this, just once again for clarity or to make the output look a little more readable. Okay. Once you have that done, then we can actually focus on how we are going to document some of our functions. And so in this particular case, what we want to do is we want to just simply start off with the name and the description, much like what we have inside or at the top of our main. And so we want to go ahead and start off with a name field followed by the description. And I'm going to do one of these, and then I'm going to pause the video and allow you a chance to get caught up. And then we can reconvene and make sure that you have gotten it correct. So to keep it simple, we're simply going to copy the entire function signature and paste it in the name comment. And then under the description, you would simply provide some sort of adequate description about the function. And so in this case, I'm just going to say calculates the area using a function pointer, or just using a function. We can be more descriptive if we would like. Now, I would encourage you to go ahead and pause the video here and go ahead and do the same for each one of your functions before we continue. All right, welcome back. So you should now have a name and description for each one of your functions. And if you notice, I've also went ahead and incorporated the earlier comment that I had regarding what the function was in the description. So you'll see here that my function 01 is a sample function, then defined as y equals to minus x squared minus 2x plus 1, and continue with the rest of our functions. Now, the next step that I would encourage you to do is to look through the document and look at some of the usage examples that I've provided for you. And please note that this is an incomplete list, but what I'd like to do is I'd like to utilize these in order to be able to turn them into our help, but also then provide us some guidance with setting up our command line switches. So once again, first thing I would suggest for you to do is to go ahead and copy them over into your help function, and then go ahead and paste them. And once again, we're going to have a little bit of cleanup to do here. As a matter of fact, if you're careful, you can once again use Control H. And what I recommend that you do is for the replace is that you go ahead and anticipate exactly what that first part is going to look like, just to give yourself a little bit of a advantage here. And what I mean by that is you can simply go ahead and put in your printf followed by your first quotes, and then you can decide, for instance, if you'd like to tab the whole thing over. And so then what I can do is I can copy and paste that pattern into my replace with, and now when I hit replace, I'll go ahead and prefix each one of my lines with the printf as well as the tab. Now it's just a matter of completing each one of the lines, in which case it's going to be a new line character followed by the double quotes, a parentheses, and a semicolon. And we can then continue that manually. And once again, the idea here is that we're just trying to speed up the process a little bit. Now, this brings us to our examples that already have quotes in them. And so what you can do here is you can do a pair of quotes next to each other. In other words, a double quote. And this will then essentially escape out the first quote. In other words, it means that we're going to want to print that inside of our printf. And now you should have a relatively complete help file or help function. Now, once again, this is just meant to be a beginning. You'll notice that we do not have certain combinations in here. For instance, you'll notice we have our by function and our by file for our left rectangle for the interactive mode. However, we did not do the right rectangle and the midpoint and so on. So we've got a lot more left to do here, but this just sort of gets you started. And then I'm going to leave the rest of those for you to do, the different combinations. Now, continuing with this, we want to take a look at our instructions up here. And you'll notice that the arguments are tiered, meaning that the first tier, or the tier 1 mode, is the /h, /i, and /p. And if you notice in the examples that we have here, they represent the first switch that comes after the executable. Likewise, if you continue to read the instructions, you'll see that the second tier switch is going to be the left rectangle, right rectangle, mid rectangle, and trapezoid, which represent the 4 numerical methods we are going to attempt to apply here. And you'll notice that they come immediately after each one of the /i's or /p's, in addition to the /compare, which we will come back to in another video. The third tier switch is going to indicate whether we're going to do this by function or by file. And if you'll notice that that switch immediately follows the type or method for the numerical integration that we're going to use here. The last thing to note with these switches is the /i and the /p. The /i indicates that you are going to be using scanfs to interact with the user. In other words, you're going to prompt the user for an input value, and they are going to enter it. The /p means that it has been accepted as a parameter, or it should be accepted as a parameter from the command line. And if you'll notice just briefly that essentially /i has no additional arguments after the function, whereas /p provides the type of function, the min, max, and then the number of data points that you expect to be using, or rather, in this case, as you're going to see, that's going to be used to determine then the interval. So before we get too deep into the individual functions, what we want to do now is we want to come up to our main, and we want to go ahead and build the triage structure that is going to allow for us to determine which of our functions to call. So what you might find useful at this point is to somehow make it possible so that you can have your instructions for this particular example up maybe on another monitor, even go so far as to print it out, or in my case, I'm going to go ahead and put it on a separate screen. Now, the idea being here is that what we want to do is we want to triage each one of our switch tiers, meaning that the first set of switches is going to either be a /h, a /i, or a /p. From then, we can determine whether or not the user intended to choose the left rectangle, the right rectangle, the trapezoidal, midpoint, or compare. Now, there are several ways that you can go about doing this. You can use a flat if structure and essentially look at each combination individually, or you can use a nested approach. For this particular example, I'm going to choose to use a nested approach, starting with my /h, /i, and /p. So to begin with, I want to recognize that no matter what, I have to provide the user with at least one argument. So in other words, your argc has to be equal to 2, or put another way, it has to be greater than 1. So what we can do is we can start off with the example here that if argc is less than 2, then essentially what we want to do here is we simply want to call our help function, because basically it indicates that there was a problem. Now, once again, I need to emphasize that there are several different ways that you can break down this problem. And in this case, what I'm wanting to do is I want to focus first on the /h, /i, and /p. And particularly what I want to do is I want to focus now on my /h. So I'll start off with an else if, and at this point then what I'm going to do is I'm going to use my string compare I function, and I'm going to compare the value that is stored in argv1, and I'm going to see if it matches my /h switch. And if that is the case, then that also means that in this case, the user meant to explicitly call help. Now, in the first example where they also called help, because they did not actually ask for the /h or ask for help, they just did not know how to run our executable. We're going to refer to this then as an implicit call for help. Now, what we want to do is we want to take a look at scenarios beyond this. And this is where you want to start looking at different options. And particularly if you notice, all of our /i combinations have one thing in common, and that is the total number of arguments. And so if you include the exe as the 0th argument, but essentially it counts as one argument, you have that followed by /i, followed by the numerical method, and then followed by whether or not it is a function or by file, which results then in a total number of arguments of 4. So what we can do is we can then start off with an else if, and we check to see that our argc is equal to 4. And then what we do is we apply then the string compare I to the argv square brackets 1. And in this case, we're going to look at the /i. If both of those conditions are met, then we at least know that the user intended to call an interactive mode. Now, they might not have gotten the third and fourth switches correct, but at least that we know they have the correct number of arguments as well as the first switch following the executable as being correct. Now, before we go into the /p mode, I'm going to drill into the /interactive mode because I'd like to finish out a couple of these examples before we investigate the more complicated combinations. So in this case, we know that we have 4 arguments in which the second argument was the interactive mode, which leads us then to triage the numerical method that we were interested in. So what we can do is, because we know that we have 4 arguments, we are guaranteed then that there should be something to compare argv square brackets 2 to. In other words, we're guaranteed there is an argv square brackets 2. And in this case, then what we want to do is we simply want to look at the different combinations. So it's a left rectangle, else if, and we're going to do a couple of these, and then we're going to start copying and pasting once you see the pattern. By the way, notice here it's supposed to be string compare I. I left off the I here on this first branch, and in this case it's going to be argv square brackets 2, and we're going to compare this then to the right rectangle. And at this point, then hopefully you start to see the pattern, and we can actually get away with a little bit of copying and pasting. Particularly what we want to do now is we want to focus on the other possibilities, which is the mid rectangle. Followed by the trapezoidal, and then the one that you can't forget then is going to be your compare. Then once you've got all those, if you somehow manage to hit the else, that means that essentially the user put in a /i for the argument immediately following the executable, but didn't really know how to use the rest of your switches. In other words, it's another implicit call for help. Now, this is once again one of the situations where you can use a flat if structure, or what you can do is nest it. In other words, what I could have done here is I could have simply then doubled up and checked for left rectangle as well as the by function or by file. Instead, what I'd like to do is I'd like to embrace the nesting for this particular example, and I'm going to only check using this nested if statement my value for argv square brackets 3. And once again, I can do that safely because earlier I was guaranteed that I was going to have 4 arguments. And so in this case, what I want to do is I want to compare that then to my 2 options for my last switch, which is going to be by function and by file. And then lastly, under the else, we will have yet again another implicit call for help. Now, the beauty of this approach is that we can actually go ahead and copy this internal template multiple times. So essentially, we know that for each one of our numerical methods, we are going to have either a by function or by file option. The only downside, of course, is that we've got a little bit of redundancy in our call for help. And we can alleviate that using other means. In other words, basically, we're calling help all over the place. No problems with that. Just be aware that there is another way to go about doing this. Now, what we want to do is we want to dig in a little deeper now to one of our nested if statements. Particularly, we're going to start off with the /i, /rectangle, and /by function. And what we want to do now is we want to leverage the fact that each one of our functions are already set up, meaning that they return a double. Now, it might not be a useful value, but it does return a double. And more importantly, that they already have a printf statement inside mentioning the name of the function that is being called. So what we want to do is we want to go ahead and create a variable called results in our main. And we simply want to use that by saying results are equal to. And now in this case, we want to think about which one of our functions we want to call. In this case, it's going to be the left rectangle by function. And so what we want to do is we want to look through our list of functions and we want to figure out which one it is that we actually want to go ahead and call. So in this case, it's going to be the left rectangle by function. And what we want to do now is we want to think about our input arguments to this function. Namely, what we want to do is we want to think about how we're going to declare each one of these variables. So for the function example, we are going to expect to pass it the pointer to a function that accepts a double and returns a double. So in this case, since we have not yet decided what function we're going to pass, we're simply going to go ahead and give it one, and I'll show you how to establish that in just a second. So we're going to start off with the cosine function. And for the min, max, and int, we're simply going to go ahead and put the variables in, and then we're going to go ahead and flush them out in just a second here. In other words, we're going to go ahead and declare them. So we would want to have an x min, an x max, and then the number of sections. All right, now, in this case, what we want to do is, since a number of our functions are actually going to share these values, then what we can do is we can go ahead and declare them much earlier. In other words, at the top of our main here. So in this case, we're going to have our x min, we're going to have our x max, and ultimately we're also going to have an int n. Now, what we want to do is to at least make sure that this particular function works. We want to go ahead and attempt to collect interactively from the user the values for x min, x max, n, and then the function that they plan on running. And if you follow along in the instructions, I ask that you provide a few of the built-in functions in C, but then also allow the user to pick either your function 01 or function 02. So if you look then at the instructions, you'll also note that I specify the order in which they are supposed to collect this information. And so we're going to start off by giving a temporary variable name called function name. So we're going to build using a char, declare using a char a function name. And in this case, we're going to hope that it is not going to exceed 20 characters. And so what you do here is you simply provide the user with a printf that says, please enter a function. And at this point, you simply use scanf and the format spec of %s rather. And what you want to do is you want to store it in then the variable function name using that address. We can repeat this now using or attempting to collect the other pieces of information. So please enter xmin. And once again, a scanf. In this case, what we're going to use is going to be %lf. And we're going to use then the address of our xmin. Continuing on now with our xmax. And then the last one, of course, is the n. So please enter an n. And the only difference here, of course, is going to be that it's going to be a %d. And we once again use an ampersand in front of our variable. Now, at this point, then, instead of simply hard coding in the function that we wish to use, instead what we're going to do is we're going to go ahead and provide yet another if statement. So we're now another level deeper here. And in this case, what we want to do is we want to triage our function name. And so we can use our string compare I, and we want to compare then the function name with one of the functions that you choose. I'm going to keep it to some of the trig functions as well as our function O1 and O2. So I'll start off with cosine. And then what I'm going to do is I'm going to leverage a little bit of copy and paste here. We're going to have an else if, and we're going to look at our sine function. And then else if, how about if we go ahead and include our tangent function. And at this point then, what I'd like for us to do is I'd like for us to look at our own custom-made functions. Oops, a little premature there on that one. Else if, and then function O2. And then under the else, we simply have another implicit call for help. Now, there is another way that you can go about doing this, but without using another temporary variable. What we want to do now is we simply want to copy and paste the line that we previously used or previously created into each one of the branches of our if statement and simply replace then what we had specified as the function. So in this case, for this sine branch, we want to replace the function with sine. For the tangent branch, tangent. And now we can also do the same thing with our own custom functions. And function O2. And you can do this for as many functions as you wish. Please note that function O1 and function O2 are probably not the best function names. Now, at this point, then, what you can do is you can go ahead and follow this up with a printf that simply specifies the area. And we haven't really gotten to this yet, but what we're ultimately going to do is we're going to have the results or the return value be the area associated with the function, with the exception for the compare function. We haven't really discussed what a logical value would be for the compare function. So in this case, I'm just going to follow this up with a F, and I'm just simply going to print out the results. And so once again, a little bit of copy and paste here, and we should be set to go pretty quickly. All right. Now, so essentially then the only difference between this particular branch and the next one, not the by file, but the right rectangle, then is simply which version of our numerical integration method that we are utilizing. So what you can do now is you can very carefully go ahead and copy, and you can go ahead and directly paste it into this branch right here. However, what I would suggest for you to do instead is simply utilize Notepad and come over here. And at this point, what we can do is we can simply paste into Notepad, and we can actually do a Control H inside of Notepad where we replace everything that says right with the word left. And at this point then, we can go ahead and copy. Actually, pardon me, I did that backwards. We did left first. So let's go back here for just a second. We want to swap everything that says left into right. And we're going to go ahead and copy this back now into our right rectangle branch. We can also go back to Notepad, and now everywhere that we say right, we can simply replace that now with mid. And once again, very carefully graft that in. And also what we can do now is we can come back over here to Notepad. We can take mid and replace it with trapezoidal. And then, of course, the last one is going to be our trapezoidal and our compare. We seem to have a little bit of a typo here. Let's go back and see if we can't fix this before we go any farther. There is no such thing as trapezoidal rectangle, so let's go ahead and replace trapezoidal rectangle, which is simply trapezoidal. And now we should be able to focus then just on our compare, which I have a feeling we're also going to have a typo in. So let's check real quick. Yes, we want to only have compare. So there we go. We'll replace compare rectangle with compare. All right, and I think we'll be done with this particular section. All right, so now that actually handles all of our interactive modes with our 5 versions here. So the function, we've collected the function, we've collected our xmin, our xmax, and our n. Now, please note that this is not the most efficient way to necessarily go about doing this. As a matter of fact, we would probably want to think about doing this with a set of flags, but this is one way to go ahead and accomplish our switch handling. Now what we want to do is we want to go ahead and handle our by file. So we're going to come back up here to the top. And once again, I encourage you to go ahead and have the help open. In other words, the documentation open so that you can understand exactly what these switches are going to look like. And so if you notice here, we're going to go ahead and assume that we've got 4 arguments, and the 4th argument was by file, which means we can now jump straight into collecting the additional information from the user. Remember, we are focusing on the /i's first, or the interactive. So what we want to do is, in addition to the variables that we are collecting for our by function approach, we also want to have a variable for our file approach. And in this case, what I'm going to do is I'm going to also create a variable. It's 20 characters long. I could potentially make it longer, but the idea here is that I want to collect the file name from the user as opposed to the function, the xmin, the xmax, and the n. So when I'm calling this interactively with one of our different methods, the last thing that I want to do is then specify the file. So we're going to follow up with a printf that says, please enter the file name, followed by the new line. And then once again, a scanf, and what we're going to do is we're going to use %s, and we're going to specify the file name. Now, in this particular case, there is no additional triaging that's going to be needed, just simply a call to the appropriate function. And in this case, then what we're going to do is we're going to simply say results is equal to, in this, we're going to focus first because we are in the left triangle branch here. We're going to say left rectangle, not left triangle, left rectangle by file. And the file that we're going to pass to it is simply going to be our file name variable. And at that point, then what we want to do is printf, and we'll just simply say area : and then %f followed by a new line, and then whatever the value is in our results variable. Now at this point, then the only thing that changes between these four lines is going to be whether we are dealing with the left rectangle, the right rectangle, the mid, trapezoidal, or the one that we cannot forget, which is going to be our compare. Once again, we'll come back to what that area is going to look like when we compare our different methods. So at this point, we've effectively handled all of the possible combinations of our interactive mode combined with our 5 different options for our methods, as well as the 2 options for by file or by function. Now what we want to do is we want to take a look at our /p options. And our /p options, now we want to think about where they fall in this nested if statement. So you want to come all the way back up at the top, and you want to think about how we triage this. So if you notice in this outer branch right here, we have an else if that looks at the arg count, and it says if arg c is equal to 4 and the string compare I of our argv square brackets 1 is interactive, then we know that we're looking at an interactive option. Now, in order to accomplish what we want to do here is we want to see if there's some sort of pattern associated with the /p options. Now, you'll notice that there are going to be a different number of options based on particularly if we're looking at by file or by function. And within a particular approach, in other words, within the by function approaches, it seems to be pretty consistent. And within the by file approaches, it seems to be pretty consistent. However, though, in both scenarios, you would agree that your argc count should be greater than 4 because at least one additional parameter needs to be provided. And then also our argv square brackets 1 is going to be equal to /p. So a good solid start here would be to look at a similar version of this statement. So in other words, if you're very careful and you follow your line down here, all the way down here to the bottom. And by the way, you can go ahead and collapse these if you wish to. But if you look at this option right here, then under else if, and if we change this now to argc greater than 4 and the /p mode, now essentially what we can do is we can only look at the parametric options. And at this point, then we can sort of further break these down and perhaps even use a different approach. Particularly what we can do is we can leverage the fact that the left rectangle, the right rectangle, the trapezoidal, and the mid rectangle, all of those approaches, as well as the compare, utilize the same number of arguments when you look at them by file, and then they also use the same number of arguments when you look at it by function. And so at this point, what you can do is you can further break this down. And you could have also, once again, you could have argued that you could have done this as a flat if structure. But once again, this example, I wanted to focus a little bit on the nested if structures. And so in this case, what we'll do is we'll say if argc is going to be equal to 5, which would be the executable, the /p, the numerical method approach, the by file switch, you would assume then that fifth argument is going to be the file name. So what we will do here is we're going to check to see if argc is equal to 5 and if string compare I, and if we compare then the argv square brackets 3, and if it matches the by file, then we're going to assume then that that last argument is actually the file name. And at this point, excuse me, then what we want to do is we want to look at what the different methods are. So in other words, we're going to be looking at our left rectangle, our right rectangle, and so on. So once again, I'm looking at this logic a little differently than I did the first time, just for comparison's sake. And so in this case, what we want to do is we want to look at the string compare I. We want to compare then our argv square brackets 2. And if it matches our left rectangle, then what that means is that we are going down the branch, if you would, where we have been provided 5 arguments. We're asked for by file, and we're looking for left rectangle, in which case then we're going to call our left rectangle by file, and we're going to pass argv square brackets 4. Now, I'm going to go ahead and set this up, and then we can dig into a particular branch here, but we're going to go ahead and say else if, a little bit of copy and paste here. We're going to look at the right rectangle, mid rectangle, trapezoidal, compare, and then the else. And once again, the else, if we've managed to somehow get here, is simply an implicit call for help. Okay, So what does this look like? Well, once again, we're going to leverage our results variable. We're going to call our left rectangle by file this time. And as opposed to a scanf and a printf, what we're going to do is we're going to rather blindly assume that our argv square brackets 4 is in fact a valid file name. From there, then what we want to do is we simply want to use a printf and say area colon %f followed by a new line and simply use the results variable. Much cleaner than the earlier examples, but this is just simply because we have a single argument, or rather a single additional argument. Now, what I've done here is I've made multiple copy and pastes, and I simply replace then the function that I'm calling. Trapezoidal. And then the last one is our compare by file. Now, we're almost there. What we want to do now is we want to take a look at the options when we are looking at our parametric mode, in other words, accepting from the command line, when we are interested in by function. And if you take a quick look again, you'll notice that if you include the executable as the first argument, it's 1, 2, 3, 4, 5, 6, 7, 8 arguments. In other words, the 0th argument is the executable. The first one is the /p mode. The second is the method. The third is by function. The fourth is the function that you wish to use. The fifth is the xmin. The sixth is the xmax. And the seventh is the n. So in other words, what you can do now is you can revise this particular condition. In other words, if you look at argc equal to 8 and string compare I equal to, or rather, let me go ahead and compare it to argv square brackets 3. And if that matches your by function, then what we're going to do is we're going to blindly assume that the additional arguments are correct. Now, left off my else if there. Now, that is a pretty dangerous assumption that we're going to make here, but it doesn't necessarily mean that it's a bad one that we can't check then later on, because we're going to have a little bit of additional logic here. But what we're going to do is we're going to take our time now to capture those arguments in our variables. And if you recall from earlier, what we had was we had a function name, an xmin, an xmax, and an n. And so what we want to do is we want to use our string copy function, and we want to copy into our function name variable whatever the value was at argv square brackets 4. All right, notice you want to take a second to pull the help up one more time to make sure that you've got the right index there. The second one that you want to utilize here is our xmin. And in this case, what we want to do is we want to use a function a2f that allows for us then to convert a string from the command line into a double. And so what we want to do is we want to convert argv square brackets 5, which should be our xmin value. Likewise, we want to go ahead and convert our argv square bracket 6 into our x max value. And then lastly, we want to use another function called a to I that allows for us to convert then a string into an integer. And specifically what we want to do is then we want to convert our argv square brackets 7. And now hopefully you can see how we're going to utilize all of our command line arguments. Now, you could argue that we were a little premature by collecting these, but rather than duplicate this portion over and over again where we were copying, you see here that we would have had to copy our argv square brackets 4 into a function name or in file name rather multiple times. What we're going to do is we're going to go ahead and pay the penalty once so that we don't have to write the code over and over again. Instead, what we're going to do is now inside of our else if, we're going to focus in on our argv square brackets 2. And specifically what we're going to do is we're going to look at argv square brackets 2, and we're going to compare it then to our different modes or different methods rather. And so specifically here, we're going to look at our left rectangle. We're going to do an else if, and we're going to look at our right rectangle. An else if for our mid rectangle. An else if for our trapezoidal. Almost there. We have a else if for our compare. And then lastly, what we're going to do is we're going to have a else, and under the else is just once again that implicit call for help. Now, let's think about where we are. In order for us to get to this point, we have to have requested parametric mode, and specifically parametric mode by function. And at that point, then the only thing left for us to do, assuming that xmin and xmax and n are all valid values, which we're going to later check inside of our functions, is that we have to triage our function name. And at this point, then what we can do here is we can just set up one last if statement where we do a string compare I on our function name. And what we can do is, once again, we can compare it to the functions that we have decided to address, in this case, our cosine, our sine, our tangent, our function O1, our function O2, then if we haven't been able to find a match, we simply once again make a call to help, and it is an implicit call because basically we got here unintentionally, meaning that the user entered in some combination that they didn't expect, that we didn't expect to handle. All right, at this point then, all that's left is to utilize our results variable once again, And what we're going to do now is we're going to make a call to our left rectangle by function. We're going to pass to it whatever function matches the string. In this case, it's going to be a cosine. And for the x min, we're just going to go ahead and assume that the value that was parsed by our a to f was usable. Likewise for our x max and also for our n. At this point, the only thing left to do then is to print f area, provide a %f, and the results. We can then make multiple copies of this. With the only thing being different is the function that we wish to call. So cosine, sine, tangent, function 01, function 02, and then at this point, we are left with only duplicating this code then based on which one of our numerical integration methods we would like to do. So in other words, for left rectangle, right rectangle, mid rectangle, and so on. And once again, this would be a great opportunity for us to go ahead and use Notepad. And what we would do here is we would simply do a Control H, and we would replace left with right. Paste our code back into this branch here. Likewise, we can replace right with mid. We can also replace mid rectangle with trapezoidal. And then lastly, trapezoidal with compare. All right, and at this point, we've written a lot of code, and we probably should have stopped and saved and compiled along the way somewhere. But effectively, if we think about it, we have functioning code, even though we have not yet written a single one of our numerical functions. At this point, we have triaged all of our switch combinations for all of our 5 potential functions, as well as for file names. So at this point, I would encourage you to go ahead and build it. And what you can do then is you can go to the command line and you can test out various different switch combinations to see if you have it correct. Now we seem to have an error here. Let's see. Oh, that one's pretty straightforward. That's simply a matter of initializing my results. I believe I've got this in multiple places. That's an easy replace. So we're actually going to do a find and replace. And everywhere we have that, we're simply going to put a equal sign in. Let's go ahead and hit replace on that. And then let's build it one more time. All right, so I believe at this point I have a dependency that's missing. In other words, what we want to do now is we want to do an include. And specifically what we want to do an include on It's going to be math.h. And that wasn't too bad. 2 mistakes with now what amounts to over 500 lines of code. The good news is, from some perspectives, that this is the hard part of this project, is simply triaging all of the different options. At this point, all we have to do now is write our numerical integration functions. And we'll do this in another video. I would encourage you to make sure that you get all of this working, and then what you would do is you would come out to your command window, and I'm just going to test a couple of these out here. Let's go ahead and cd them to my documents. In this case, courses, E233, my projects directory, and we're going to go ahead and go into my numerical demo. And there we go. There's our numerical demo.exe. And I'm going to start off with, does my help work? And sure enough, it does work. What happens if I don't provide a switch? That's looking promising. What if I provide a /i but nothing else? All right, so we've got a little bit of work to do here. Let's go back real quick and figure out why we didn't call help here. So we'll go back here to our main. Basically, we have an argc that was greater than 2. That part's fine. I think what happened is, and I recall making a mental note to myself that we needed to add this down here. If you notice, I'm very careful about where I'm keeping my cursor here. I believe that what we did here is we never had a follow-up to this else if. And so if you follow this cursor down one more time, there we go. I believe we need to sneak one more help in here. Once again, an implicit call for help. And we'll go ahead and build it. And now when we do our /i, we should be set. Now, just a last suggestion on this video, this is probably a great place for you to go ahead and start writing your batch file, in which case what you will do is you can go ahead and test each one of our examples here. And particularly what I want to do is I want to check on just one random example. I'm going to do the /p. How about if we do left underscore rectangle. And more importantly, what I want to do is I want to do my by file, and I want to provide it with a sample file name, in this case, something like input_01.csv. And if you notice, I am calling left rectangle by file, and I'm actually returning an area of 0, which essentially is just the initial value for results. But you can see now the benefit of putting that printf statement in here. So before you go any further, what I'd recommend that you do is set this up and make sure that you can successfully call each one of your functions. All right, so hopefully you found this video useful, albeit a little bit long. I tried to be very, very, very explicit here, so you might find yourself fast forwarding around this video, which is perfectly okay. But if you've got any questions or comments, don't hesitate to email me, and thank you for watching.